Okay, so for 10-2 special right triangles, there are two types of special right triangles, and they're on two different pages of the note, so please make sure you write down both parts. You can write it on one piece of paper, I just have it currently separated into two. So the first one is 45, 45, 90 triangles, and the second one is 30, 60, 90, okay? So I'm going to start by talking about the 45, 45, 90 triangle. Now when we see this, we'll see a right triangle just like we did with Pythagorean theorem, but we're going to actually see a 45 degrees. Now we don't need both 45 degrees to know that it's a 45, 45, 90 triangle, because if one of these is 45, automatically the other one is going to have to be 45. So even if we just see one 45-degree angle, that's enough to tell us that we are going to be doing a 45, 45, 90 triangle. Now the great thing about this is these are shortcuts. Sometimes it's required that you use these, which is why we have to learn them. So like Pythagorean triples with 10-1, you needed to learn them because they were a nice shortcut, but you didn't always have to use them. You could always use the Pythagorean theorem as a backup. With this, especially with the 30, 60, 90 triangle, sometimes you'll only be given one side, so that's not enough information to use the Pythagorean theorem. So with this, what this is saying is in a 45, 45, 90 triangle, if I know both of these legs are going to be the same, because then this is, if we have two equal angles, we have two equal sides. It's an isosceles right triangle. So if both of these sides are equal, without even having to do the Pythagorean theorem, I know that the hypotenuse is going to be whatever the side length is times the square root of 2, okay? These are s's, it's not a 5, just as a heads up. So for example, if I know, this is a question that we did on our warm-up today, if I know that each leg is 8, and it's a right triangle, and it's got a little 45 degrees in here, I could do the Pythagorean theorem right here to figure out what this is, okay? 8 squared plus 8 squared, 64 plus 64, I get 128, I do the square root of 128. No matter what, I'm going to end up with just 8 square root 2 here. Now I could do that instead of going through all the steps of doing the Pythagorean theorem here, which is really incredible. Okay, so the hypotenuse is just the leg times the square root of 2. So whatever the leg is, both legs are the same, times the square root of 2. Now what about if we were given the hypotenuse? Well, that's pretty simple. If I was given the hypotenuse was 8 square root 2, and if to get the hypotenuse I did leg times the square root of 2, I would just have to divide by the square root of 2. So I would say 8 square root 2 divided by the square root of 2. Well, that's pretty simple. Those cancel out, and I'm just left with 8 in both these situations. So that's another handy part. Well, what about when this doesn't have the square root of 2? So let's look at that. What if it just says, I'm going to go with 20, and it's a 45, 45, 90 triangle, okay? So to find the legs, I'm going to call these x. Both of them are going to be called x because they're both the same. I could do x squared plus x squared equals 20 squared. This is 2x divided by 2, all of those things. But there's a simpler way. I can just divide by the square root of 2. 20 divided by the square root of 2. Now the only issue here is I don't end up in the same situation I ended in up here, where I had square root of 2 over square root of 2 and they canceled out. Now can I just pretend like there's a square root of 2 here? Absolutely not. Can I just pretend this square root is not here and just say divided by 2 equals 10? Absolutely not. Here's the steps we actually have to follow, because this is our answer. This is just an irrational answer. We can't leave the square root in the denominator. Especially on Math Excel, you have to rationalize the denominator or else it will not accept your answer. So in order to rationalize the denominator, so we divided, now we rationalize, and then we'll simplify. So to rationalize the denominator, we multiply by the number 1. Now 1 could be anything. 2 over 1 is 1, right? 10 over 1 is 1. Or sorry, 10 over 10 is 1. 100 over 100 is 1. So we can make 1 be any number over itself. So like this equals 1. Now we just want to pick a really smart 1. So in order to get the square root out of the denominator, remember, when we have a square root times a square root, so I can just multiply by whatever in the denominator, but I have to multiply by 1, so I put it over square root of 2. So that is 1. So I'm not changing the problem at all. Now, when I do square root of 2 times square root of 2, there's some behind the scenes work happening here. Because it says when we multiply square roots, square root rule, square root of a times square root of b is the square root of a times b. So the hidden work behind here is we're saying square root of 2 times the square root of 2 equals the square root of 4. Well, I know the square root of 4 equals 2. So here's the thing, when we have two of the exact same square roots and we're multiplying them, the square root just disappears. And here's the behind the scenes work that makes it happen. Okay, so let's actually do that. So we'll have, on top, we'll have 20 times the square root of 2, 20 times the square root of 2, and on the bottom, as our work over here tells us, the square root of 2 times the square root of 2 is just 2. So we divided. We rationalize, that's this step, where we multiply by square root of 2 over square root of 2. And now we just have to simplify. What's 20 divided by 2? Well, that's 10 square root 2. It doesn't go into the square root, it only goes into the 20. This is our answer for what x equals right here and right here. They're both going to be the same. So that's a very important thing to understand. I'm going to talk about one more example using this situation, and that would be if we had a right triangle and we had, let's say, 7 square root, let's just go with 8, okay? Now that's, if this is a 45, 45, 90 triangle, that's our hypotenuse. So to find the legs, I would do hypotenuse divided by the square root of 2. Now this works just the same way. We would divide the square root into the square root. I could rationalize this, but that's more steps than we need. 8 divided by 2, that's 4, so it's 7 square root 4, and that's what my legs are. Okay, so I just wanted to show that it's also possible even when it's not just a square root of 2. We don't just say this is 7, this is 7. No, it's 7 square root 4. Okay, that's the only way. So those are the types of situations you might run into. These two are the absolute easiest. If we're given just regular numbers here, it's just 8 square root 2. This one's a little bit harder where we have to divide, rationalize, and simplify. This one is still pretty simple, just might be odd. And then the last one we might see is, what if it says like 4 square root 2 here? 4 square root 2. Well, those are my legs. To find the hypotenuse, I just do leg times the square root of 2. 4 square root 2 times square root 2. The square roots multiply. And really, I'm going to use a different number here, just that way we can see. I'm going to use 3. So I'm going to have 4 square root 3 times the square root of 2, and so I end up with 4 square root 6. Sorry for changing the problem on you. I just wanted to show you that it would just multiply. Square root of 3 times the square root of 2. It would just multiply and go there. Okay? So those are the situations for 10-2 for 45, 45, 90 triangles. Okay? Remember, we still have 30, 60, 90 to talk about. So those were all the possible situations. And remember, sometimes it's as easy as this is 8, this is 8, this is 8 square root 2. That's going to be the majority of problems you see in which you're using 45, 45, 90. It's only the rare situations in which you'll see the other ones. Okay? Now, if it ever asks for a decimal answer, because like I don't accept decimal answers, but sometimes there's problems that specifically ask for a decimal answer. So the way you put 5 square root 2 into like your phone calculator, let me show you that real quick. Let me turn my calculator sideways. Sorry. Calculator. So I would do 2 square root times 5 equals. So that's what 5 square root 2 would equal. Let me show you that one more time. So I did 2 square root, you don't have to press shift on the phone calculator, that's for the in-class calculators, times 5. Okay? So that's important to understand for 45, 45, 90s. Now let's talk about 30, 60, 90s. Very important as well. So for 30, 60, 90s, we have a long leg, a short leg, and a hypotenuse. Now here's the thing, once again, if we see the number 30 or the number 60 in our angles, automatically we know it's going to be a 30, 60, 90 triangle. Now they're not always going to be in this exact format, so while this picture is very handy, sometimes it might be flipped. We might have it look like this, 30, 60, 90, or we may even have it look like this, 30, 60, 90. We just have to be very careful. Remember, the short side is always the side across from the 30. The smallest angle, smallest side is across from it. Okay? The hypotenuse is always the right angle, and then the long leg is the one across from the 60. Okay? So let's keep that in mind. And you could even have, I don't know, 30, 60, 90. Okay? So it could be in any different orientation. Just make sure you're paying attention to which one's your short leg. Short leg is the key here. This is where we base everything off of. So if we're given the short leg, for example, if I gave you that this short leg was 6, then you could find everything else. The hypotenuse is just 2 times the short leg. So if the short leg is 6, the hypotenuse is 12. And then for the long leg, it's just the short leg times the square root of 3. So it's just 6 square root 3. Now this is a very wonderful shortcut. But if we were just given 6 and told to find both other legs, we couldn't have used the Pythagorean theorem. You need at least 2 of the sides to use Pythagorean theorem, unless both the sides are the same, like in 45, 45, 90, which is why it's so important to understand the 30, 60, 90 triangle, okay? And everything is based off the short leg, so always find the short leg first. For example, if we were given the hypotenuse first instead of the short leg, we shouldn't try to go from the hypotenuse to the long leg. We should first find the short leg. So I made my hypotenuse 20, okay? So then I should find my short leg. My short leg is just the hypotenuse divided by 2. So 20 divided by 2 is 10. So now that I know my short leg, I know that my long leg is just my short leg times the square root of 3. So 10 square root of 3. Pretty simple there, okay? But what if we were given the long leg? Okay, so I'm going to show you 2 different situations in which we might be given the long leg. So one of them could just be as easy as we're given 4 square root 3. I'm given the long leg, and that's the only thing I'm given. I know this is the long leg because it's across from the 60-degree angle. Well, to find the short leg, because everything's based off the short leg, I shouldn't try to jump to the hypotenuse. To find the short leg, I just do the long leg divided by the square root of 3. Well, if the square root of 3 is already in it, those just cancel out, and the short leg is 4, and I can find the hypotenuse is 2 times 4, which is 8. Okay? Now, the hardest type of this problem would be the situation where we're given a long leg, but it doesn't have the square root of 3 attached to it. So I'm going to show that as, I'm going to do 18. Okay? That's my long leg, but it doesn't have the square root of 3. So we don't want to confuse it for the short leg. We shouldn't just be like, oh, this is 18 square root 3, and this is, what, 36. That's not how this works. This is our long leg, so in order to do that, we have to divide by the square root of 3. And we end up with the same problem that we did in 45, 45, 90. So we end up with a square root in the denominator, which means we have to rationalize. This time, we're choosing our one even more smart. We're not using square root of 2 over square root of 2. We're using square root of 3 over square root of 3. Okay? Now we can rationalize equals, so remember, square root of 3 times square root of 3. So square root of 9, square root of 9 equals 3. And then I have 18 square root of 3 on top. And then simplify. 18 divided by 3 is 6 square root 3. Now that I know my short leg is 6 square root 3, I know my hypotenuse is just 2 times the short leg. So I do 2 times 6 is 12 square root 3. That's the only other type of situation that you might run into. There are plenty more example problems in the textbook and across the board. So like this one, we're given the long leg is just 5. So we have to divide, rationalize, and then it doesn't really simplify on that one. It just stays 5 square root 3 over 3. Highly recommend looking at the example problems in the textbook and on Savas. But I did a lot of example problems with you guys right here, showing you all the different possibilities in which you might run into this, okay? So make sure you have both of these triangles written down. Make sure you're using them carefully and not mistaking one for the other. Make sure you're double checking the orientation on this one, and just be careful when you're solving these problems. But special right triangles are really important because they save us a lot of work, because it's just, I mean, I did 9 problems during this time using special right triangles, and that is much faster than doing Pythagorean theorem. Have a great day. That's what 10-2 special right triangles is all about.